Touchdown! NASA's Mars Perseverance rover safely lands on Red Planet. Less than a day after NASA's Mars 2020 Perseverance rover successfully landed on the surface of Mars, engineers and scientists at the agency's Jet Propulsion Laboratory in Southern California were hard at work, awaiting the next transmissions from Perseverance. As data gradually came in, relayed by several spacecraft orbiting the Red Planet, the Perseverance team were relieved to see the rover's health reports, which showed everything appeared to be working as expected. Like its predecessor, Curiosity, which has been exploring Mars since 2012, Perseverance is a semi-autonomous mobile science platform the size of a small car. It's designed to spend years roving the Red Planet, looking for, among other things, any evidence of microbial life that may have thrived on Mars in the past. Why is NASA Perseverance important? How Perseverance will search for signs of life? And how will the Mars rover return to Earth? But before we answer these questions, make sure to subscribe and hit the notification bell to be notified as soon as new videos are uploaded. Many dozens of spacecraft have visited the Red Planet since the 1960s, and a good portion made it down safely to the surface, too. We found evidence of water, organics, methane, and more. While the chance of ancient life on Mars appear high, the arguments that we should explore the Red Planet because it's a potential habitable world holds less weight when you remember Mars is not the only such place in our neighborhood. Scientists have tracked spurting water at Saturn's Muse Enceladus and Jupiter's moon Europa, to name a few potential habitable water ice worlds in our solar system. The car-sized Perseverance rover, the centerpiece of NASA's $2.7 billion Mars 2020 mission, will hunt for signs of ancient life, collect and cache samples for future return to Earth, and help demonstrate a variety of new exploration technologies, among other tasks. Perseverance is carrying an advanced payload of science instruments to gather information about Mars' geology, atmosphere, environmental conditions, and potential biosignatures. Mastcam-Z, an advanced camera system to help study surface minerals. META, Spanish-built sensor suite to measure temperature, wind speed and direction, pressure, humidity, and dust. MOXIE, experiment to demonstrate how astronauts might produce oxygen from Martian CO2 for breathing and fuel. Pixel has an X-ray spectrometer to identify chemical elements and a camera that takes close-up images of rock and soil textures. RIMFAX, a Norwegian-built ground-penetrating radar that will map geology beneath the surface at centimeter scales. SHERLOC will use speedometers, a laser and camera to hunt for organics and minerals that were altered by water. SuperCam will examine rock and soil with a camera, laser, and spectrometers to look for organic compounds. Perseverance carries 7 scientific investigations and processes a total of 19 cameras and 2 microphones. The rover is carrying the mini helicopter Ingenuity, an experimental aircraft that will attempt the first powered flight on another planet. The Rover Body. The Perseverance rover relies on the successful design of the Mars Science Laboratory rover, Curiosity. However, Perseverance has a new science and technology toolbox. An important difference is that this rover can sample and cache minerals. To do so, Perseverance has new coring drill to collect samples. The samples are then sealed in tubes and placed on the surface of Mars. In the future, another space mission could potentially pick up the samples and bring them to Earth for detailed analysis. While the overall design of both rovers is very similar, including the radiostype thermoelectric generator as a butt-mounted power source, Perseverance builds on the experience that JPL has with Curiosity, resulting in a larger, more durable, and more capable robot. Perseverance is only a few centimeters larger than Curiosity, but it's over 100 kilograms heavier. Much of that extra chunk comes from a substantial heavier turret on the end of its robotic arm, which includes a coring drill. There are a bunch of other new scientific instruments as well, which we'll get to in just a minute. Perseverance also has 5 more cameras than Curiosity, and while its primary imaging camera is still only 2 megapixels, Perseverance version has a 28 to 100 millimeter optical zoom. And for the first time, Perseverance will be taking along a couple of microphones so that we can hear what Mars sounds like. One of the problems that Curiosity has been having on Mars is wheel wear, and so Perseverance was designed with beefier wheels. Perseverance's aluminum wheels are 1 millimeter thicker, with a tread pattern that's more resistant to wear caused by sharp rocks without sacrificing performance on sand. Gone, sadly, are the rectangular wheel cutouts that spell JPL in Morse code as Curiosity drives along. Perhaps the most significant difference between the two rovers is software, is that Perseverance is much more autonomous than Curiosity. It'll be able to plan its own drilling paths, travel further each day. We'll be covering this in more detail in a separate post. Curiosity, by the way, is still making her way up Mount Sharp and clocking its 3,000th day on Mars last month with a total distance traveled of over 24 kilometers. Searching for life in NASA's Perseverance, Mars samples. NASA's Mars 2020 Perseverance rover will be the agency's 9th mission to land on the red planet, along with characterizing the planet's geology and climate and paving the way for human exploration beyond the moon. The rover is focused on astrobiology, or the study of life throughout the universe. Perseverance is tasked with searching for telltale signs that microbial life may have lived on Mars billions of years ago. It'll collect rock core samples and metal tubes. Subsequent NASA missions, in cooperation with ESA, European Space Agency, would send spacecraft to Mars to collect these sealed samples from the surface and return them to Earth for in-depth analysis. To quote Carl Sagan and Gentry Lee, chief engineer for the Planetary Science Directorate and NASA's Jet Propulsion Laboratory, if we see a hedgehog staring in the camera, we would know there's current and certainly ancient life on Mars, but based on our past experiences, such an event is extremely unlikely. Extraordinary claims require extraordinary evidence, and the discovery that life existed elsewhere in the universe would certainly be extraordinary. The Mars 2020 mission scientists believe that Jezero crater, the landing site for Perseverance, could be home to such evidence. They know that 3.5 billion years ago, Jezero was the site of a large lake, complete with its own river delta. They believe that while the water may be long gone, somewhere within the 28-mile wide, 45-kilometer wide crater, or perhaps along its 2,000-foot tall, 610-meter tall rim, biosignatures, evidence that life once existed there, could be waiting. We expect the best places to look for biosignatures would be in Jezero's lake bed or in the shoreline sediments that could be encrusted with carbonate minerals, which are especially good at preserving certain kinds of fossilized life on Earth, said Ken Wilford, Deputy Project Scientist for the Mars 2020 Perseverance rover mission at JPL. But as we search for evidence of ancient microbes in an ancient alien world, it's important to keep an open mind. NASA's 5th rover to the 4th planet from the Sun carries a new suite of scientific instruments to build on the discoveries of NASA's Curiosity rover, which have found that parts of Mars could have supported microbial life billions of years ago. How Perseverance will hunt for signs of past life. A survey of the minerals in Jezero crater by Dr. Brian E. Horgan of Purdue University, Dr. Melissa Rice of Western Washington University, both scientists on the mission, and colleagues, revealed carbonate deposits at the western edge of the ancient shore. These marginal carbonates were likened to a bathtub ring, the buildup of soap scum that's left after the water is drained. Terrestrial carbonites can lock up biological evidence within their crystals. One type of structure that sometimes survives is a stromatolite. These are formed when many millimeter scale layers of bacteria and sediment build up over time into large structures, sometimes with dome shapes. On Earth, they occur along ancient shorelines where sunlight and water are plentiful. Billions of years ago, Jezero Shore was exactly the kind of place where stromatolites could have formed and have been preserved. Perseverance will examine the carbonite-rich bathtub ring with its science instruments to see whether structures like this ever formed there. An instrument called SHERLOC captures close-up images of an interesting rock and produces a detailed map of the minerals present, including any organics. Another instrument called Pixel will then give scientists a detailed elemental or chemical composition of the same area. Within the dataset, scientists will look for concentrations of biologically important elements, minerals, and molecules, including organic matter. In particular, it's when these things are concentrated in shapes that are potentially suggestive of biology, says Ken Wilford. Drawing together many lines of evidence is vital. Visual identification alone won't be enough to convince scientists of a biological origin. Given the high bar of claims of extraterrestrial life, short of a huge surprise, finds are likely to be described only as potential biosignatures until rocks are sent to Earth for analysis. The team for Jezero Crater. The Mars 2020 Perseverance team is made up of scientists and engineers from multiple disciplines, with international participation from countries and organizations around the world. The science teams include principal investigators from the US, Spain, and Norway, while numerous individuals make vital contributions without which the mission would not occur. Key team members include John B. McNamee as the project manager, Matthew T. Wallace as the deputy project manager, Jennifer Trosper as the deputy project manager, surface developer and ops, and Gun Xing Chen as the advisor to project management. And that's it for today's video. Don't forget to smash that like button, share this video with your friends, and tell us what you want to see next in the comment section down below.